Number 13, a physics student wants to hit a target with a rubber ball from 1.8 meters away. If he throws the ball at a speed of 6 meters per second, and the target is the exact same height as where the ball is thrown, what angle from the horizontal must he throw the ball to hit the target? All right, so we do have a distance away, so that's 1.8 meters, and we're looking to solve for the angle, right? So we need to get theta all by itself. If we can solve for theta, we'd be done. This equation that I've written down here, this is the projectile motion equation. I've derived all three for total time of flight, total time to the peak, the range, which is what we're using here, as well as the maximum height. I've solved for all three of them on a separate YouTube video, and it's called Projectile Motion Equation Derivation. So you'll see how all of these equations have been derived. So this just didn't magically appear. This we actually derived on another YouTube video. So let's see if we can get theta all by itself here. All right, so the first thing that we could do is we could multiply both sides by g. Okay. Then we can divide both sides by v naught squared and 2. And we're left with sine theta. We can take the inverse sign so that theta will now be by itself. Theta equals rg times 2 times v naught square inverse sine. All right. Now what we can do is plug in our numbers. So our range is 1.8 times g all over 2 times our initial velocity, which they said was 6 squared. And we have to take the inverse sine of that. And when we put that in our calculator, we come up with 14.47 degrees, which is closest to 15.